Okay, exponential functions. Determine whether each function is an example of exponential growth or decay, then find the y-intercept. I don't need you to find the y-intercept. You got to determine if it's growth or decay. Now you can do that with a table, or you can look at the exponent's base. I'll do the first two at the table, and here I'll decide on the base. Okay, you pick which way works for you. So y equals 5 times 3 to the x power. So if I make a table, I would just put 0, 1, 2 since I don't have to graph it. Now 5 times 3 to the 0 power is 5 because 3 to the 0 is 1. 5 times 1 is 5. Now the next one, 3 to the 1 is 3, and 5 times 3 is 15. Okay. And then if you put 2 in, 3 to the second is 9 times 5 is 45. Obviously growth. Okay, next one. Y equals 7 times 0.5 to the power of x. So my independent variable is a power. That's why it's an exponent function, but is it growth or decay? So we're going to go 0, 1, 2. First one's going to, by the way, the y-intercept up here would be 5. It's whatever you get when you put 0 in for x, because 0 on x is on the y-axis. Okay, so I got 7 as anticipated. 7 times 0.5 is 3.5. And then to the 2 power, 1.75. That's decay. Okay. Okay, now there's a way to tell growth and decay without making the table. Okay. You identify what the exponent's base is right there, and 10 over 3 is bigger than 1. Okay. Bigger than 1, so that means it's growth. Okay, y equals 0.5 times 2/5 to the x power. That is a 2 over 5. Okay, so that 2/5 is less than 1, and that's a decay. Again, if you have a fraction, the larger number's on top, it's going to be growth, but if it's on the denominator, it's decay. Okay, next problem. Graph the function, identify the domain and the range. So we have y equals 2 times 2 to the power of x minus 2 and then minus 4. So if you have a power, you know how this is going to work. You want to parenthesize the power along with the base. And if the power's got an operation with it, you're going to block it off. So you're just dealing with 2 to the x when you make your input-output table. You need an input-output table, and you also need the asymptote before you graph the coordinates. You got to know that line you can't cross, what it approaches. So now, two ways to set up a table. Is this growth or decay? Well, that base 2, that's bigger than 1, so it's growth. So if it's growth, I'm going to go with the 2's first, and then negative 10 finds my asymptote, which will be expressed as y. So I go 2 to the second power, that's 4, and this would be 1/4. 2 to the first power is 2, this would be 1/2. 2 to the 0 is 1. And then if you take 2 to the negative 10th power, it's going to be a really small decimal because it's the same as 1 divided by 2 to the regular 10th. That approaches 0. So it approaches 0. That's what those wavy lines mean. Okay, now I've got some operations. So in the exponent, you got a minus 2. Within the exponent does the opposite operational effect to the x. So you'll add 2 to all your x's. Now the outside of your base exponent, those operations have the same effect to the y, and that includes the asymptote. So you times 2 and you minus 4. So that's 4, 3, 2, 1, 0. And then negative 10 plus 2 is negative 8. Even though I'm not going to graph it, I do it. Then 4 times 2 is 8, minus 4 is 4. That was just by luck. 2 times 2 is 4, minus 4 is 0. 1 times 2 is 2, minus 4 is negative 2. 1/2 times 2 minus 4 is negative 3. And then 1 ABC 4 times 2 minus 4 is negative 3.5. Now you also have to ditch the asymptote because you take the 0 times 2, 0, and then subtract 4, it's negative 4. So the asymptote is negative 4. Now looking through my outputs, I can have the y be worth 1s. Okay? So I have to set up my asymptote first, -4, 1, 2, 3, 4. And then from there, 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. 3, 0, 1, 2, 3. And then 2, -2. And then you know what happens from there. You just get upward infinitely, then you go against the asymptote right there. Now domain and range. The domain is all real numbers. You can pick anything you want for x and put it in. Because I can take 2 to the power of anything. There's no restriction on what I can evaluate the 2 to. Now the range, we put the y with its asymptote value, and then just look at the graph. It's above, okay? And also, if you look at your -4, these other y values are greater, okay? So it's greater than -4. If it's below, it would be less than. Okay, graph the function, identify the domain and range. Now a logarithm, okay? First off, with a log, you need to make a little table over here for later, okay? You will have an asymptote, but it's not going to be expressed as y over here. Okay, now first we have to switch the x and the y around. So x replaces as the y and y replaces the x. Now you got to get the y by itself. Now if it's after a log and a base, you want to parenthesize that. You got an operation outside. You got to take out the +3 with a -3. So now we have x minus 3 equals log base 2 of x. Now you get rid of the log by using the base 2. This is the base's power, x minus 3, and then this x is your product. Y. This y is my product, sorry. It's y. It's y. Y. Okay. Okay, so now I rewrite it. The product goes by itself. That's good. Now y is by itself. Now you put your base 2, put the caret symbol, and then x minus 3. So you parenthesize the base exponent. Okay. Separate the -3 from the x and the exponent. You make your table, just like you did on the last one. So asymptote. Y equals. So the 2, the base on the exponent is higher than 1, so it's a growth. Okay. So 2, 1, 0, -1, -2, -10. So 2 to the power of 2 is 4, and that'd be 1/4. 2 to the 1 is 2, and this would be 1/2. 2 to the 0 is 1. And then this, as we know, approaches 0. Now, inside the exponent, you have a -3, so you +3 to your x's, and the y is going to stay because you don't have any outside operations with the base and the exponent. So 2 + 3 is 5, 4, 3, 2, 1, -7. And the y is going to stay the way it is. Okay, so the asymptote is going to be 0. Now, since you had to switch the y and the x around, which is what you should do, you want to switch these. So now 4, 5. That's how you graph an inverse. 2, 4. 1, 3. 1/2, 2. 1/4, 1. And then 0, -7. Now our asymptote is still 0, but instead of y, it's x. So now you go on the x-axis to 0. That's in the middle. And now the asymptote is going to be vertical instead of horizontal. So 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 2, 4, 1, 3. And then we see what happens. We go extreme that way, and then here we just slide against the asymptote. So now the domain range is also flipped. Okay, so the range is now all. Okay, the domain, we put our x with our 0. Now I want you to look at these right here. Look at your x values. They're higher than 0. Okay, higher, so greater than 0. Okay, now Okay, write each equation in logarithm form. Okay, so again, here you go. 3 to the second equals 9, 3 is a base, 2 is a power, 9 is a product. That's the same as this, okay? So equals, you write the word log, base 6 goes here as a subscript, and the power, the 2 goes here all by it, the 4 goes here all by itself, and then 1, 2, 9, 6. Okay, next one, same way. Log, put your base. Negative 2 goes on the other side, then 0.0625 goes right there. Okay. Easy enough. Now you're evaluating the logarithm, you're figuring out what it equals. Okay. So you're figuring out how many factors of 2 it takes to multiply to 16. So 2 times 2 is 4, 2 times 2 times 2 is 8, 2 times 2 times 2 is 16, so we're there. So how many 2's is that? It's 4 of them, so it's equal to 4. 2 to the 4th is 16. Okay, next one, same deal. Base 4, 16. 4 times 4 times 4 is 64. So how many factors of 4 is that? It's 3. So 3. Okay, log base 15 of 225. So base 15 times 15. That right there is 225. Use your calculator, so it takes 2. Okay, 5. Now what if I'm multiplying by the reciprocal of an integer? Well, you put a negative sign and then you just go with the 125. 5 times 5 is 25 times 5 is 125. But since it's 1 over 125, it's negative 3. Because 5 to the negative third power is 1 over 125. Okay, write the expression as a single logarithm. Okay, so log 3 times log base 4 of x minus 2 times log base, that's a 4 there, believe it or not, of x. Get these coefficients over here, and they go as exponents on your product. Okay, and that's not supposed to be an x either. That's supposed to be a y. Okay, that is supposed to be a y, not an x. Okay, so I write log base 4, make a parentheses, and x to the third. Minus means you're going to put division, so it's x to the third divided by y to the second. There you have it. Okay, condensed it. Okay, expand into multiple logarithms. So you put a parentheses, and how many logarithms do you need when you expand it? Well, you have 3 factors, a 7, an a to the third, and a b to the second. So you write 3 of them. Okay, so I got 7, a to the third, so that exponent needs to come around here as a coefficient. And then b to the second, and that 2 comes around, that's a coefficient. Okay, so this is multiplying, so we expand it out using addition. Okay. Okay, now it gets a little bit tougher, the equations. The first 2 aren't bad. Okay. Solve each equation. So you're solving for the x. 5 to the 2x power equals 125. Okay. So what do we got going on with the x variable? Well, that variable is a power. So parenthesize the base and the exponent. Undo outside operations. We don't have anything. There's not a times in front. There's no plus or minus behind, so we're good there. Then we're either going to do the COB, or if the base is E, we take ln off of each side. Well, the base is not E, okay? So what I do is I take do the COB. I take my power, 2x, the power equals log over log. So 2x log. Okay, so you put your base 5 on bottom, 125 on top. So 2x, then you find what log 125 divided by log 5 is, and that's 3. Okay, now you got to divide by 2 then to find the actual x value, and 3 divided by 2 is 1.5. So you've solved it. Okay, next one, base 6 to the x plus 2 power equals 30. So I'm solving for x, and the variable once again is a power. So, parenthesize the base and the exponent. Undo any outside operations. You don't have any of those. Okay. So we're using COB if the base is actually a number. If the base is E, we're taking ln off each side. Well, the base is definitely not E. So I circle that, and I'm using the COB formula. Okay, by taking that exponent, x plus 2, and setting it equal to the log over the log. So the base 6 is in the denominator, 30 is in the numerator. The answer to this is not 5. Okay. 6 to the what power is 30? Well, it's some irrational decimal. Okay, so 1.90. Then you minus 2, minus 2. 1.90 minus 2 is going to be negative 0.1. Okay, number 17. 6 times log base 3 of x equals 18. So I'm solving for x, and the variable is not a power here. The variable is in a logarithm, so I'm just going to put log underneath it. And that's what I'm going to look. Make sure there's only one log or natural log, and there is, log base 3, so we're good there. Parenthesize the log base and product and undo any outside operations. So log base product is right there. You have a times 6 you need to undo. You would divide by 6 then. So that takes us to 3. So we have log base 3 of x equals 3. Okay, now you either rewrite into an exponent, or if you have ln, you take the e power from each side. Well, we don't have ln, that's a log base 3, so I'm going to rewrite it into an exponent. Remember how to do that. This is the base, the other side is your power, and the x is your product. So we have base 3 to the third power equals x. Okay, and then x is easy to solve for. 3 to the, you just do 3. It's not 9. 3 times 3 times 3 is not 9. It's 27. Okay. Okay, moving right along. 5 times e to the 2x power equals 300. So I need to solve for the x variable. E is not your variable. The variable's x. And now we're back to having the x in a power. Okay. So you parenthesize the base and the exponent. Undo outside operations. You got a times 5, so you need to divide by 5. That takes you to 60. Now it's an OR, okay? Use a COB if your base is an actual number, but if the base is E, you take the ln off each side. So we're not going to be doing the COB, we're going to be taking the ln from each side. That will cancel. And then I have just the linear expression 2x. Then I take ln 60, and that's going to be 4.09. Okay, so 2 times x equals 4.09, so then you divide each side by 2. And 4.09 divided by 2 is 2.05. There's your answer. Okay, number 19, ln of x plus 2, the natural log of x plus 2, plus ln, the natural log of x minus 2, equals 4. So we're back to solving for x, okay, and the variable's in a logarithm. ln is a logarithm. It's a natural logarithm. So you make sure there's only one log or ln, okay? There's not. There's 2. So we have to condense then. So you write ln one time. And you're going to put x plus 2, and then if I see a plus, it's going to be multiplication of x minus 2 equals 4. So we condense it with plus. You got to know those properties. It's times. Okay, parenthesize log base and product, undo any operations. So I'm pretty much already got my parentheses made. You can make it right there if you want. Now, Can you rewrite it into an exponent, or do you have to if you have ln, you take the e power from each side? So we have ln, so we put these power symbols and we put e. Now what that does is it cancels the ELN side. Now I need to find what this product is, okay? So I need to FOIL. So I take x times x, then x times -2, then 2 times x, and 2 times -2. So we have x to the second, we have -2x, we have +2x, which cancels, that's good, then -4. So over here I have the expression x to the second minus 4. Now on the other side we need to take our e to the power of 4. So second ln gets you to the e function. So it's 54.60. Okay, now I'm solving for x to the second power, but it's x to the second only. Okay, so I apply the linear properties. By that I mean add 4 to both sides. Then you make a radical of it 2. Okay, so plus 4 plus 4. So 54.60 plus 4 is 58.6. Now you eliminate the power with a radical. It's an inverse operation of a power. Okay. So since 2 is an even, I need the positive and the negative, which means I will have 2 answers. And I go 2 second caret 58.6. And I got 7.66. Remember, ln is a logarithm. You make sure there's only one of them. Parenthesize. There were no operations on that side. Now we couldn't rewrite it in an exponent because it was a natural log instead of log with an actual number base. If you have ln, you take the e power from each side. Remember to simplify that side though. Okay. So we ended up with x second, and so forth. Okay, story problems. 20. A deposit of $8,000 earns 3% interest compounded quarterly. Find the value of the account after 15 years. Okay. All right, so compound, there's a compound formula. You don't need to do the a, it's not ab to the x power. A is equal to p multiplied by 1 plus r divided by n caret, and then n times t. Okay, we got to know what these are. Actually, no, a goes behind it. My bad. Okay, a goes behind it. So p, r, n, t, and a. So p and a both stand for money. Okay, p is where you started at, which is 8,000. Okay, and the a is where you ended at, which you don't know. So you're going to keep that a as a variable. Now your r. Okay, that's your percentage. So 3%, you need to rewrite it as a decimal. So 0.03 is my r. Now my n, quarterly, there's 4 quarters in a year. And then the t value is 15. Okay. All right, now you fill in your equation. So p is 8,000. 1 plus, and my r is going to be 0.03 divided by my n, which is 4. Then n times t, so it's going to be 4 times 15 equals a. So you simplify your exponent in your parentheses, so that's 60. And you also need to find out what your base is by evaluating within the parentheses. So 1 plus 0.03 divided by 4, 1.0075. So now I have a much cleaner equation. I've simplified it. And I'm going to solve for a. Okay. Well, a is very easy to solve for. Okay. Since the variable is all by itself, you simply evaluate the other side. Okay. I mean, that's the easiest equation there is. So 8,000 times 1.0075 raised to the 60th power at $12,525.45. That's your answer. Next problem. A delivery fan costs $25,000. It depreciates. That means it goes down at a rate of 15% per year. Approximately how many years will it take for the van to get to a value of $6,000? Now we're not dealing with compound, okay? So we need to write our base exponent function. Dollars in years. Years is X, dollars is Y. So per, dollars per year. Okay. Now we don't have a dollars per year, instead it's by percentage. Okay. And that percentage is 15%. Okay. So that makes this into an exponent function because you wouldn't be adding every time. The operation would be repeated multiplication. You have to know the factor, which is quite easy to find. Take 100, make sure you're minusing because it's depreciate means it goes down. So it's 85%. So 0.85 is my exponent factor. Okay, so my exponent function starts as a times b to the x power equals y. So a, b, x, and y. Remember, the y and the a stand for money, both of them. Whatever the y is, the a will stand for the same thing. The a is where you began at, 25,000, and then where you ended at, that's 6,000. Now the b we know is 0.85, that's your factor. The x is unknown because that's the answer to the problem, so it stays x. So you fill this in, 25,000 times 0.85 to the x power, and then y is 6,000. So we're solving for x, okay? Variable is x, and that variable is a power, okay? So it's a power. So you do what you normally do, parenthesize the base exponent. Undo outside operations, so you have a times 25,000, you need to divide by the 25,000. And 6,000 divided by 25,000, 0.24. Okay, now you're clear of the operations. Since your base is a number and not E, you're going to do the COB formula. Or that's not, the base is not E, so I go COB. So I take that exponent, that's equal to the log over log. That's a change of base formula. Finds the exponent every time as long as the base is 0.85. So 0.85 here, 0.24 on top. You always put the base on bottom. So log 0.24 divided by log 0.85, and I come up with 8.78. So that's what x is, and that's approximately how many years that is. Okay, last problem. Skip the page on you. The initial value of a car is $25,000. The value decreases by a constant percentage rate each year. After 4 years, the car has a value of $10,240. What's the car's depreciation rate? So you are finding the percent now. You still have your 2 units with dollars and years. So per dollars per year. Now, there is no dollars, it's a percentage, but the percentage is unknown, so I put question mark. Alright, so that means it's going to be an exponent function, and the factor we just have to leave as b, okay? So a times b to the x power equals y, so we have to know what the a, the b, the x, and the y are. So we do y and a first, because they stand for the same thing. Y is money, and a is money. So you got 25,000, that's your first a value. Then 10,240. Now the b, we don't have a replacement, so that's why the b stays b. Okay, x is years, and the years is 4. So you have 25,000 times b to the x, and then to the 4th power, 10,240. So now we're solving for the b variable. Now what's b? Is b a power? No, power is 4. Is Do we have a logarithm in this equation? Heck no. The variable's to a power, okay? It's to that power and only, okay? Decide if you have to factor or use linear properties with a radical. Well, we don't have to factor because b to the fourth power is the only degree I have b to. It's b to the fourth only. So I need to use the linear properties, properties, and then use a radical 4 then to solve for the b. Use a root to solve for it. You don't have to move everything to one side and factor. Now, because we have just only b to the fourth. So you divide by 25,000. That means b to the fourth power. 10,240 divided by 25,000 is 0.496. 4096. Now you get rid of this and use a fourth root to solve for it. Again, when that variable is to a power, okay, if that's the only power the variable's to, you're going to use the linear properties followed by a radical. You will not need to factor on this test, okay? Okay, so remember how to do this. 4 second caret 0.4096, and I come up with 0.8. Okay, that's your b value, but it's not necessarily the percentage. Okay, so you take your 0.8 and you always minus 1, and that's negative 0.2. Move the decimal twice to the right. 1, 2. Fill that in with a 0, and that's 20%. Negative 20%.